Hello everyone, I am Saket Purval and I will teach you network analysis. It's a very good subject and hope you will enjoy it. So I will take some introduction to the network analysis, what is it exactly, and some network elements and their types, some conventions and some concepts. So firstly I am starting with network. What we mean by network? So network is a interconnection of network elements in a proper way that can give some output. So this is the network. So I have to define network elements for this also. Because so what are network elements? The elements which one can use in the network state, they follow some laws in the network, and so these are called network elements, and we can say that these are of two types. One are active elements and passive. This is a very broad classification of network elements. So what are active elements? Active network elements are the elements that can give power or energy. It doesn't mean that it cannot absorb power. They absorb power. For example, your battery is simply an active element and it also charges, so it also absorbs power. Passive elements are simply the elements which consumes power, like resistors, inductors, capacitors, also diodes. Some books classify diode as an active element, some say that it is a passive element, and all semiconductor devices come into this category, active elements, and all sources also come into this category. And all semiconductor devices. Because they are inbuilt, they are a junction which is a battery, so that's why they come in this category, active elements. So now I am coming to the sources. So how many type of sources we have? Sources, we have independent sources as well as dependent sources. So we have two types of sources, independent sources and dependent sources. As the name is telling, they are very obvious what we mean by independent sources. It is simply a battery. A battery is an independent source. Its voltage does not depend on any other voltage in a network if it is connected in a network. And dependent sources are the sources which depend on some other parameter, other current or voltage. So these are known as dependent sources. Generally, they may be a voltage source and current source. Simply dependent sources. So now I am firstly coming to this. What is a voltage source? What is the definition of ideal voltage source? What are the characteristics of these ideal independent sources? So now I am coming to ideal voltage source. So what is the ideal source? Suppose I have a voltage source. This is how one can represent an independent source by this simply. This is a voltage source and one can draw infinite amount of current from it. If one can draw infinite amount of current from this source, then it is very okay. This is very good source, and it is one of the most important characteristic of the ideal voltage source. So, if one can draw any amount of current from the source, then it will be ideal voltage source. Now, if suppose we have a current source also, and corollary is like corollary theorem. If I can make up some voltage across it, and if I can make up infinite amount of voltage across it, and then I will say this current is also ideal source. But obviously, in practice, all the sources are not ideal. Sources are practical, and one can model practical sources using these ideal sources. One can draw an equivalent circuit of these practical sources using ideal voltage sources. So suppose I am drawing so in practice, this source can give a finite amount of current for a finite amount of time. See, this is the concept. If I am drawing the current from this source and I cannot draw some finite amount of current, which is the rating, maximum rating of this voltage source, like I said, it can give I max. The maximum current it can give is I max. So what is the reason behind it, and how can we model this practical voltage source using this ideal voltage source? Simply, if I am drawing the current from this source, the voltage at the terminals always drops. If I am drawing a current and the current is increasing, then the voltage across the terminal is also dropping. If the voltage drops, then what does it mean? That there should be a series resistor across which some voltage is dropping. If there is a current I and this is a resistance R, which can be said that it has some internal resistance R, and there is a voltage drop I into R, and these are the terminal voltage V. Small v is the terminal voltage, Vs is the rating of that voltage source. So if I plot a graph, this is current I. So V versus I. If I plot this, then voltage drops linearly. Here this voltage V is Vs minus I into R. But some voltage is dropping here. If this node has voltage Vs, then the voltage at the terminal will be Vs minus I into R. Is that okay? So, if the source were ideal, then this characteristic will be like this. If I am drawing any amount of current, the voltage is fixed, which is Vs. But in practice, this voltage goes down as I increase the current I. So, your graph will be like this has some negative slope. So, voltage drops as I increase the amount of current which I am drawing from this source. Simply, one can also explain this concept for current sources also. Okay. So we can also explain this concept for current source also, and there will be a source. This is the ideal voltage, ideal current source with some parallel resistance, which is also ideal. And this is the terminal current at the terminal I. And this is the voltage at the terminal P. So if I increase this voltage, then there will be more leakage of the current. So the current at the terminals will be dropping also. So for current source, I am drawing the same plot. So if this is, let us say, V in horizontal axis, I am taking voltage at the terminals, and the current also in vertical axis, current is also obtained at the terminals. So this, if the source is ideal, then this current is always constant. How much voltage you can apply, any amount of voltage you can apply around this current source, so that will be the leakage current, and this I will drop. So again, this is for practical source, and this is for ideal. This is the ideal source, this last constant line, and this is the practical source. So this is the one of the limitation of the practical sources. So again, now I am coming to some basic understanding of networks. So let us take some questions. So my first question is, what is a network and what is a circuit? And if you know, then tell me in this example which is a network and which is a circuit. These are the two circuits. So we have to tell which one is the network and which one is the circuit. So first I will define the definition of this network again. It is simply an arrangement or interconnection of electrical elements. Network is simply the arrangement and interconnection of network elements. And what is a circuit? An energized network is called circuit. Again I am repeating, an energized network is called circuit. So tell me, what is this? What are these? So it is a network. Yes, it is a network. And is this a network? Again, the answer is yes. This is also a network. And what about the circuit? Is this a circuit? No, this is not a circuit. This is only a network. Yes, this is a circuit. Because it has some current flowing in this, and this network has some energy, it is in excited state. So this is a circuit, and all these two are the arrangements or interconnection of network elements. So these are the networks. So one can say that all circuits are network, but all network are not circuits. So this statement I will write. All circuits So this is a statement. All circuits are network, but all networks are not circuit. Now come to another understanding. What is a mesh and what is a loop? So now mesh versus loop. So what is a mesh and what is a loop? So now what is a mesh? And loop. Any closed path in a circuit or more generalized network is called loop. Any closed path in a network is called loop. And the smallest closed path in a network which cannot be further divided is called mesh. This is the definition. Again I am repeating. Any closed path in a network is called loop, but the smallest or elementary closed path in a network is called mesh, which cannot be further divided. So I am giving a simple circuit again, and you have to tell me what are the number of meshes and what are the number of loops in that network. Again, I am making a network. So let us say this is a network. So it's a very simple network, only 3 resistors, and this network is also known as simply T network. So I am marking all the points in this network, A, B, C. Let us see P. So, how many meshes and loops this network has? This is my question. You see the network and tell me. So now I am coming to the meshes. How many meshes? This network. Obviously, it has 2 meshes. So number of meshes is 2. So there are 2 meshes. In this network, and what are these? Simply A, B, D, P. And B, C, Q, D. These are the 2 meshes. And what are the loops in the network? How many loops are there in this network? Again, there are 2 loops A, B, D, P, B, C, Q, D. These are the 2 loops also. And there is another loop which is this bigger loop A, C, Q, and P. So there are 3. Number of loops are 3 in this network. And again, if I name them, this is one extra loop. A, C, Q, P. So this loop is the one which is extra, and the remaining 2 are the meshes also. So those meshes are also loops. So again, we can make a general statement that all meshes are loops, but all loops are not meshes. So again, one can say that loop is a more generalized term than mesh. Is that okay? So one can say that all mesh are loops, but this is the first one. This is a statement. So one can say that loop is more generalized than mesh. Is this concept clear? Okay. So now I am coming to another basic understanding of the course, that is what are the junctions and nodes. So my next this topic will be junction versus nodes. So junction versus nodes, or simply node. Again, junction is very obvious. A point in a network where current divides or distributed is called junction. But what is node? Any point in a network which has some different potential than the previous one is called node. Again, I am repeating, any point in a network which has some different potential is called node. So this is the definition of node. And what is the definition of junction? Any point in a network where current distribute or divide is called junction. Again, I will make a network and you have to tell me how many junctions this network has, and also the nodes, and also what are these nodes. Again, very simple network. Let's say Instagram. So again, I am marking the points, and you have to tell me how many number of nodes and junctions this network has. So this is A, B, C, and this is P, this is Q, and this is R. So how many nodes and how many junctions? So again, where current can divide, I think at this terminal current cannot divide, but at this point current can divide. So this is a junction. So this is a junction. Okay. Junction. And again, current can divide there also. So this is also a junction. And how many nodes? Again, what was the definition? Any point in a network which has some different potential than the previous one is called node. Let us say this node has 0 potential. Let us start with data node. This is the reference node we will take in. So again, this, let us say this is of voltage Vs. This is voltage source of voltage Vs. So this A node is having potential Vs, which is again different from this. So this P is a node and A is also a node. But what about Q and R? This whole is a single node. This whole is a single node, Why? Because this has same potential. All the potentials, all are simply connected by wire. This has same potential, which is 0 volt. And what about A? A is a node. This is a node. B is a node. Yes, B is a node. C is also a node. So we have 1, 2, 3, 4 nodes, but 2 junctions in this network. Is this concept clear? Yes. So this is the basic difference between node versus junction. And later on we will study if you know the nodal voltages or voltages of all the junctions in a network. If you know the voltages of all the junctions in a network or potential of all the junctions in a network, then you know everything about that network. And if you know all the current flowing in the meshes, which are called mesh current, I have not defined till what is a mesh current. If you know all the mesh current of a network, then again you know each and everything about that network. So there are famous two analysis techniques, that are mesh analysis and nodal analysis techniques. So that we will study. This is a very powerful tool in a network. If you know these two tools then you know each and everything in networks also. It is very easy subject. So now I am coming to the dependent sources. Again, a dependent source may be a voltage source, it may be a current source. Again, it can depend on a voltage or on a current also. So a dependent source may be a voltage source as well as current source. So clear. So if I take the classic division of these, so it may depend on voltage. It may depend on current. So there will be current dependent source, there may be voltage dependent source, and again this may be a voltage source and it may be a current source. Same here. Will be current source also. So have you seen dependent sources earlier? What are these? Can you give the example of a dependent source? I think all you have seen these dependent sources in the whole curriculum or whole engineering. I mean, very simple example. These all are simply the amplifiers. All the amplifiers are the dependent sources. Again, an amplifier may be voltage dependent, current dependent, and we represent these voltage source by a dimension. Let us say this is kVx, this is the source. There is some output voltage kVx. Input voltage to this source is Vx, and it is multiplying that voltage by K. So output is simply amplified by K. If amplification is greater than 1, this K is greater than 1, then it will be amplification. And if this is less than 1, then it will be attenuation. So this is known as the amplification factor of the source. Amplification factor. And this is the dependent variable or control variable. Again, it should have 4 terminals, one for input voltage and another two terminals for another plate for output voltage. So in network analysis, for the sake of simplicity, we always draw this as a two-terminal device by knowing that it is a four-terminal device. So every dependent source will have a control variable and an amplification or attenuation factor. If this k is less than 1, it may be attenuation factor. Okay, so these are simply the dependent sources. Also, they consume power. Again, they are all semiconductor devices. They are made up of semiconductor devices like op-amps, transistor, and so on. So we come into the category of active network elements. Is that okay? So now I am coming to a very simple concept of power absorbed or supplied by a source. So when we will say a source is supplying the power, and when we will say a source is absorbing the power, or in more general terms, when we say a battery is charging, and when we will say a battery is giving power to us, to a circuit. So if I have a voltage source, or if I have a battery, and if the current is flowing in this direction to the battery, then if the current is flowing in this direction, then I will say this source is giving the power to the circuit, or it is supplying the power to the circuit. This source may be voltage independent source as well as dependent source. If it is supplying the current to us, then we will say it is supplying the power to us, but the direction of current should be outward from the positive plate of the battery or positive terminal of the voltage source. If the case is opposite, if the current direction is this, like this, then we will say this battery is charging and it is absorbing the power. And how much power? Simply, if this is simply the product of voltage and current. This I is this current, and voltage is voltage across the plates. And this source is absorbing the power. And how much power? Again, this V into I. This is a very simple concept, and one should know this concept. Many questions have been asked in GATE also on this concept. I will take some questions also. So again, if I say for this current source, if the polarity of the voltage across the current source is like this, positive terminal is above and negative is below, then I will say it is supplying the power. And again, how much power is the product of these two, V into I. And if the case is opposite and this absorbing the power, the polarity is like this, minus plus, this is the voltage across this, then it is absorbing the power. And how much power? Again, same product of current and voltage. Is that okay? So now I want to take some questions. Some of these questions have been asked in GATE also. Okay, so let us take first question. I am making the circuit. Okay, I want to take some conventions in networks first. conventions in network analysis. Suppose I have a network like this. So, let us say there is not any resistance, and what is the current flowing here? 10 by 7 is very simple. We used to register in series and voltage upon the resistances. Some of the resistance is the current. This is a series network. So, again, if current is flowing in this direction, so there will be drop across this 2 ohm resistor. So I would say, what is the polarity of this drop across 2 ohm resistor? Voltage drop across this resistor. What should be the polarity if current is flowing in this direction? It's very simple. Current always flows from higher potential to lower potential. So the polarity of the voltage across this 2, the plus sign here and minus sign here. Again, current is here. The polarity of the voltage across this 5 ohm resistor will be like this. Voltage is dropping. This node has voltage 10 volts. Some of the voltage drop here, the remaining is here. So if voltage drops and it is becoming from plus to minus. If the voltage is becoming plus to minus, then it is dropping. And if voltage is becoming minus to plus, then it is simply rising. So that is the voltage rise and this is the voltage drop. That's why we have always voltage drop, because the voltage is becoming plus from plus to minus. Very simple concept. So if a current flows, then plus polarity will become first and then there will be minus polarity of the voltage. So this is the basic concept, and this is the main convention in the circuit theory, and ongoing in this course we will be familiar with all the conventions as far as needed. So now I am taking a simple example. This is some simple interconnection of ideal voltage sources. Okay. My question is, find that which source is absorbing the power and which source is delivering the power, and how much power they are delivering or absorbing. This is question. So how much energy they are, or how much power they are delivering or absorbing. This is a very simple question. Is that okay? So that we have to find. So what is the way of finding this? First, take the reference node. If you have a voltmeter in your hand, then you will measure some voltage. There will be 2 pins. One is black and one is red. The black one is simply the reference, whereas red one is at the node of the voltage to be measured. So let us say I will connect the black one here, and if I connect the red one here, what is the voltage? Again, I am simply connecting this voltmeter across this 10 volt source. It is very obvious that the voltage will be 10 volts here. Is that okay? So voltage of this node is 10 volt. So the voltage of this also 10. This node is also having 10 volt. Okay. So the polarity of the voltage across this 4 ampere source is like this, and the voltage is 10 volt. So when you say, is it absorbing the power or delivering the power? Again, it is very simple. It is absorbing the power. We have studied this concept. And how much power? 40 watts. 10 into 4. It is 40 watts. Now, what is the nodal voltage of this node? This node has 10 volt, and if I travel here, then there is a transition from plus to minus. So the voltage is dropping. And how much volt has dropped here? It is 8. And previously I was having 10 volt. So the remaining is 2 volt, very simple. So I have voltage across this 2 ampere source, which is equal to 2 volt. Is that okay? So how much power? Is it delivering the power or is it absorbing the power? It's very simple. It is, the polarity is like this, plus is above and minus polarity is below. So it is delivering the power, and how much power it is of 4 watts. This is 2 into 2. So now I am come to this voltage across this. Again, this node has 10 volt. So the polarity of this voltage across this is again 10 volt, because this is 0, this is 10. So polarity will be like this. And so one can say that it is simply absorbing the power. How much power? 30 watts. And again, if you want to know it is delivering the power or absorbing the power, you have to find the current flowing from this source, 10 volt source. For this you have to apply KCL. You all have studied KCL in 12th. So this is a 2 ampere current, and this is a 4 ampere current, and this current is of 3 ampere. So what should be this? Very simply algebraic sum of all the currents incoming and outgoing to the node is equal to 0. So this current is of 2 ampere, this is of 4 ampere, this we don't know, and this is of 3 ampere. So what should be Ix flowing from here? So the summation of incoming current should be equal to the summation of outgoing current, and so one can say that Ix plus 4 plus 3 is equal to 2. Okay, so this is 7, 2 minus 7 is, so Ix is minus 5, or one can say that here is a current which is of 5 ampere in this direction, opposite to Ix, because Ix is negative. So this voltage source is delivering the power. How much power again? 50 watts. So this is absorbing the power. If a source is absorbing the power, I will count as negative power. Okay, and if a source is delivering the power, it will be taken as positive. So how much power it is delivering? Plus 4 watts, and this one is what about this 8 volt source? Again, it is delivering the power. The current direction is like this. It is outgoing to the positive terminal, so it has 16 watts. And this one is absorbing the power, so I will take as negative. So this is minus 40 watts. Again, this is 50 watts and this is minus 30 watts. Again, one can check the law of conservation of energy. One can verify also that total power absorbed should be equal to total power delivered. So, how much power delivered totally? Is 4 plus 60 plus 50. It is 70 watts, and one again, and this is minus 40 and this is minus 30, total is 70. So it is following the law of conservation of energy, which is always true. So this question is clear. On that question also, we have question asked in the gate. Now I am taking a question which has asked in gate paper 2009. It has been asked in 2009. So let us take this question. It's very simple. Again, this is simply interconnection of the ideal voltage sources. This is of 60 volts. This is unknown I amperes current source. This is 20 volt and this is of 12 ampere. And it is known that this 60 volt current is delivering the power. This is given in the question. It is known that 60 volt source is, it is absorbing the power. This source is absorbing the power. It means the direction of the current is incoming to this positive terminal of the source. So this 60 volt source is absorbing the power. Then they have given 4 options, find I. So if this source is absorbing the power, this source is absorbing power, then what should be I? From these 4 options, I am giving you the options also. It is 10 ampere, 13 ampere, option C is 15 ampere, option D is 18 amps. We know the direction of the current to the 60 volt source is like this. It cannot be inverted. It is known that it is absorbing the power. Then what should be I from these 4 options? If any option is violating this condition that the current is outgoing, okay, then it will not be the correct answer. Let us say I take 15 amps. Let us say I is 15 amp. So the amount of current flowing here is 15 amp. And it is known that the direction of current is like this. And there is incoming current is 13 amp. So it is very obvious that if current is 13 ampere, then it will provide the current. This 60 volt source will provide some current. So it will not be absorbing the power at that stage. So this current I should be less than 13. It should be less than 13. Then only this 60 volt source can absorb the power. Then only the direction will be like this, downward direction. So I have only one option which is less than 13. But what about the 13 amps itself? It will be neither absorbing nor delivering power. If I is 13, then this current will be 0. So at that point, at that stage of point, one can say that it is neither absorbing the power nor delivering the power. Okay. So this question is clear. This question has asked in GATE 2009 also. It's very simple one. So now I am taking another question which is of GATE 2009 again. This is time axis. This is instant of 10 minutes. This is 12. This is 10 volts. So again, one can see that if you are drawing the current from source, its voltage is dropping. But again, see that this is the time axis, not the current axis. So one source cannot give. A source cannot give a current for infinite amount of time. Okay, so this is the voltage waveform which is the voltage waveform which is supplied by, which is given by a battery in a mobile phone. Okay, and it is given that this battery is giving same amount of current, constant current, IT of 2 ampere for this 10 minutes. It is giving 2 ampere of current for this duration, and the voltage waveform is like this. So the question is how much energy this battery has given to the mobile. Okay, so how much energy this voltage source battery has given to the mobile circuit. So again, it is very simple. You can find the instantaneous power. What is instantaneous power? Power is also changing according to the time. So at any instant, there will be different types of. For every instant, there will be different value of the power. So that's why we are calling this instantaneous power. If I am multiplying this voltage by current, then what I will get? Instantaneous power. Okay, and if one wants to calculate the total energy supplied by the source in that duration, so you have to take the area of this curve, instantaneous power curve. So I am multiplying. Okay, what will be the waveform of this current source? It is simply 2 amperes up to 10 minutes. This is current. So if I want to multiply this curve by this curve, so I will get instantaneous power. Okay, so multiply this by 2 amperes, what you will get? Again, you are multiplying by a constant, so the shape of the graph will not change. Only some slope will be changing, but this shape, this is decaying, it will remain as it is. So if I am multiplying by 2, if I multiply this by 2, then what I get? 24, 12, the voltage here was 12, 12 into 2 is 24, and this is 10. This was 10, so after multiplying by 2, it will be 20. So this will be the curve for instantaneous power. Okay. If I want to find the total energy supplied, again, what is the definition of power? The energy supplied per second is called power. 1 watt is 1 joule per second. Always remember this fundamental. These are the basics. So one can easily find the area of this curve. So what is the area? If I am calculating the area of this curve, what I am doing? I am multiplying the time to the power, so I will get energy. So the area of this curve will be equal to the energy supplied by the source. Okay, and this is a trapezoid. The formula for trapezoid is half into sum of parallel sides multiplied by this height or this base, one can say that. Okay, So half multiplied the sum of parallel sides. What are parallel sides here? This is 24 and this one is 20. This is of 24 and this is of 20. So what I will get? 20 plus 24. This is 44. And again this is the main width of this trapezoid. It is of 10 minutes. And 1 minute is equal to 60 seconds. So this will be 60. I'm multiplying this by 60. So you can calculate this and you can have your power. So this will be 22. 22 is to 6. This much joules you have, or 30.2 kilojoule. So this much of energy is supplied by the battery to the mobile. This is 30. Is this question clear? It's a very simple question. And we will do many questions in this course like this. It's very interesting. Again, in next lecture, we want to discuss mesh analysis, nodal analysis, and simply voltage divider and current divider rules and their applications also. So, thank you.